These are your 2-3 notes on solving equations with multiple steps. So this time we're going to be solving with a combination of either having to add and then divide or multiply and subtract. So a combination of steps. In this section, we're also going to introduce, I'm going to introduce consecutive integers and how you solve equations using consecutive integers. Kind of a difficult concepts for Algebra 1 students, but I think we'll be okay. So working backwards through the equation, you want to add or subtract first. Again, that whole backwards process of PEMDAS. Multiply or divide second. That's kind of a guideline. Talking through the problem helps explaining what is happening to the variable. So ask yourself, and this is what I'll ask you when I come to your desk, what's happening to the variable? And if you can explain to me what's going on. Is it being multiplied? Is it being divided by something? We can rewind your conversation and take care of the thing that happened last. This is just a sort of a rule of thumb, but sometimes we'll end up multiplying first. It just depends on the problem, but majority of the time, this is what you can count on. So if you look at number 1, if I ask myself the same question I'm going to ask you when we start doing these, what is going on with Q? So if you describe if Q was a number, if that variable was a number, we'd multiply it by 2. And then add 11. So I might just keep track of that. I'd multiply it. It's being multiplied by 2, and then we're adding 11. So if you rewind that statement and go backwards, we got to take care of the add 11 first. So I'm going to subtract 11 first. Then we'll take care of the multiply by 2, which is divide by 2. So I'm going to get rid of the plus 11. I need to make that positive 11 turn into 0. So using my additive inverse, I'm going to subtract 11 from both sides using the subtraction property. Whatever I do to one side, I have to do to the other. I'm going to bring down the 2q. Everything else gets brought down. Bring my equal side down right in line. And then 3 take away 11 is negative 8. Not done yet. I don't have the value of q. I want to get q all by itself. Q is being divided by 2. Or I'm sorry, multiplied by 2. So I'm going to divide by 2. 2 divided by 2 becomes 1q, or just q. And that's equal to negative 8 divided by 2, which is negative 4. So just the same thing we did the day before, but now this time we're doing it in 2 steps. There may be more than 1 step involved. When we check, same as before, 2q plus 11 equals 3. Write down the original problem. Plug the variable in with parentheses so you don't mess up any signs and operations. When I plug the negative 4 in, this is really telling me to multiply 2 and negative 4, which makes negative 8. Plus 11 is equal to 3. We're asking ourselves, is this true? Is this true? A negative 8 plus 11 is, in fact, 3. 3 is matching the other side 3. That tells me that those two numbers, 3 is always 3. So that tells me that Q must equal negative 4. So 2 steps. The second example, this is kind of breaking the rule of multiplying or adding or subtracting first and then multiplying second. So if you were to read this following the order of operations, the very first thing that would happen is that we're adding 9 to k. And then we're dividing by 12. So when I try to reverse that and try to undo that, the last thing I have to do first. So since we're dividing by 12 last, I need to multiply both sides by 12 first, and then I'm going to subtract 9. So I want to get rid of that 12 first. When I do that, I want to put parentheses around this because I'm multiplying the entire side by 12. So I'm going to multiply this whole thing by 12. And whatever I do to one side, I'm going to do to the other side. So I see a times by 12 times by 12. When you times something by 12 and then end up dividing by 12, it's like it never happened. So I cancel it out. K plus 9 then is equal to negative 24, because that's negative 2 times 12. To get rid of the plus 9, I'm going to subtract 9 from both sides. Draw my line. It's an equal sign. K equals negative 24. Take away 9. Use your calculator. It's negative 33. A lot of you make mistakes with your signs. If I go to check this, I'm going to use the original problem. Write down everything the same, k plus 9 all over 12 is equal to negative 2. Negative 33 plus 9 divided by 12, is that equal to negative 2? We're checking. That's why I put a question mark there. I don't know if they're equal. If I can make all of this equal this, I know that I'm balanced. Negative 33 plus 9 is negative 24 over 12. Is that equal to negative 2? And negative 24 divided by 12 is negative 2. So that's a formal check. And the reason I show you all of the steps of the formal check, we're going to be checking our work in class. But the idea behind it is that you can have 100% on these quizzes and tests that we take because you can check every single answer. All right, here's our story problem. Susan had a $10 coupon for the purchase of any item. She bought a coat that was on sale for half its original price. After using the coupon, Susan paid $125 for, typo, the coat. Before taxes, what was the original price of the coat? So write an equation for this problem and solve. The original price of the coat, why don't we call that C? C is the coat price. If you know anything about a coupon, $10 coupon for the purchase of any item, and then there was sales. So coupons, subtract $10, and half of its original price takes half of that cost. We know that when she was all said and done, she paid $125. We're not really worried about taxes here. So if I take the coat price, divide it in half, divide it by 2, or take half of it, either way, subtract $10 from it, that equaled $125. So the coat price divided by 2, taking half of it, subtract $10 for the coupon, equaled $125. So in this case, I want to add 10 to both sides first to get rid of that addition or that subtraction. When I add 10 to both sides, the negative 10 and the positive 10 cancel. C divided by 2 is equal to 135. And so what that tells me is the price of the coat, if the coupon wasn't applied, it would be $10 more. And then to divide by 2, or take half of the price, I'm going to multiply by 2. Whatever I do to one side, I have to do to the other. And so this right here doubles the 135 and makes the jacket $2, or the coat $270. Okay, that was the original price of the coat. Working backwards to solve. All right, now we got to talk about these lovely consecutive integers. So here's a graphic. I would like you guys, I know I have it all in there. I'm just going to go quickly through it. And when you have consecutive integers, we just learned what integers means in chapter 1. They're the nice positive and negative whole numbers, so no fractions, no decimals, integers. Consecutive means in a row, right? In order. Consecutive wins means they won, 8 consecutive wins means they never lost. Consecutive days, it hasn't rained for 30 consecutive days. That means within 30 days, no rain. Consecutive years, same idea. So when we talk about consecutive integers, they're integers that come in counting order. So here's your example. 0, 1, 2, 23, 24, 25. You can start anywhere on the number line as long as they're in order. Okay, consecutive even integers is just counting by the evens. So negative 2, 0, 2, 4, 18, 20, 22. You can start anywhere on the number line as long as you start with an even and then keep counting evens. And then the same thing goes for odds. We can go with 1, 3, 5, 7, 9, 11, as long as you start with an odd anywhere on the number line and continue that pattern. Now, symbolically, if we don't know what the integers are, we use variables. If you notice in each of these cases, the first variable is n each time. Some number. I don't know what the number is. N could be 3, n could be 6, n could be negative 15 for all we know. It's where you go from there. That's your first number. So n is my first integer. Then to get to my next integer, what do we have to do to get to that next number? You add 1 to it, and that would be my second consecutive integer. If I start with 4, how do I get to 5? I add 1. If I start with 10, how do I get to 11? I add 1. Now, if you notice, for the evens and the odds, we're not going to add 1 each time because we want to skip that next number and go to the following one. So if I was at 10, to get to 12, I have to add 2. If I'm at 20, to get to 22, I have to add 2. Same thing goes for odd. If I start counting at 5, to get to the next consecutive odd number, I'd have to add 2 to make 7. And if I start there, I have to add another 2 to get to 9. So 5 plus 2 is 7, plus 2 is 9. So that, actually, I did plus 2, which is plus 4. It gets a little confusing, but if you can understand this pattern right here, you'll be in good hands. So let's go ahead and try some. Find 3 consecutive integers whose sum is 21. So sum means I'm adding them up, and is means equals. So this tells me after I add them up, they're going to equal 21. 3 consecutive in a row integers. So they didn't say even or odd. So what I need from you to, when we do this, is we're going to define them. N is my first integer. And to get to my next number, since we're not doing evens or odds, I'm going to add 1 to get to the next number. That's my second integer. And to get to the next one, I'd have to add 1 to that. So n plus 1 plus 1, or we can call that n plus 2, is my third consecutive integer. So now that I define my variables, these are my 3 numbers. N is a number, n plus 1 is a number, and n plus 2 is a number. I know you guys probably don't like those parentheses. So if I consider these 3 things as my numbers, the sum would look like this. Here's my first integer, here's my second integer, and here's my third. I have 3 integers added together, and they equal 21. So we have to write the equation here. That's part of the reason why Algebra 1 kids, not a big fan of these. Combine like terms, I can see that I have 1 n here, another n here, and another n here. I have 3 n's. And I have a plus 1 here and a plus 2 here. I have plus 3 is equal to 21. Now I have an equation that we've seen before. I need to subtract 3 first, get rid of that 3, bring down the 3n is equal to, when I subtract 3 from 21, I get 18. Divide by 3, n is equal to 6. Now, they didn't ask me just for the first integer. They want to find the 3 consecutive integers. If n is my first, and that's 6, if I add 1 to 6, I get 7. And if I add 2 to 6, I get 8. So 6, 7, and 8 are my solutions. They're in a row. They're whole numbers. And if I add them up, they do, in fact, equal 21. So you can always check your answer that way. Guess and check. Kids try to use guess and check here. You get 0 credit. So I don't care if you get the right answer or not. I need to see the work. Let's try another one here. Find 3 consecutive odd integers. Again, we're going to define them. N is my first odd. N plus 2 then is my second odd. How do I get from 5 to 7? I have to add 2. How do I get from 5 to 9? I have to add 4 from the original problem. There's my 3 consecutive odd integers with a sum of 57. So I'm going to add them up. The first plus the second plus the third is equal to 57. There's 3 numbers here. Here's my first, here's my second, here's my third. There's 3 n's, and there's a plus 6 there. The 2 and the 4 make plus 6. So I cleaned up my equation, and now we're ready to solve. I'm going to subtract 6 from both sides. 3n, these cancel, is equal to 51. I'm going to divide by 3, divide by 3, n is equal to, when you divide 51 by 3, you get 17. So the first odd, first of all, you want to make sure that it's odd and that it's a whole number because it's an integer, which it is. So n is 17. My next odd would be 19 consecutive, and the next one would be 21. So my solutions are 17, 19, and 21. If you add all of those up, you will, in fact, get 57, like it says. All right, so your lesson summary here is to give me an example of 3 consecutive integers, just any 3 on the number line, and then I want you to solve that equation for me. Good luck.